Okay, this video is an introduction to probability distributions. So we have two types that fall under the umbrella of probability distribution. So we have discrete and we have continuous. So earlier on we learned about discrete and continuous variables. So we're going to use that information to better understand different probability distributions. So discrete, if you remember, discrete variables take on a whole number of values such as 0, 1, 2, 3, whereas continuous takes on any number those numbers plus the numbers that fall in between them. So discrete would be how many cars do you purchase, whereas continuous would be something, how much does a shipment weigh. So discrete is only going to take on whole numbers 0, 1, 2, 3, whereas continuous could be 1.2333 or whatever. So in chapter 5 we're going to focus on discrete probability distribution. Specifically we're going to focus on the binomial and the Poisson. And then in chapter 6 we focus on continuous probability distributions. So a lot of the terminology is a little bit confusing, but then once we see the pictures and we use it, I think it makes more sense. So let's talk a little bit about terminology, and then we'll talk about an example. So a random variable is a numerical description of the outcome of an experiment. So that's a little bit confusing, but like I said, an example is going to make better sense of it. And then a probability distribution, we're talking about them. What are they? They describe how probabilities are distributed over the values of a random variable. Okay, so again, probably not making too much sense. We're going to get there, don't worry. We use random variables and the values they take on to create probability distributions so that we can determine probabilities of events. Okay, so let's look at a picture to kind of make sense of this. So taking a step back, let's look at this example. This is the number of customers making a purchase when they go into a store, and then the probability of purchase. So looking at this graph, this is showing that what is the probability that one person makes a purchase? It's about somewhere around probably 0.45. So what is this? This right here, the number of customers making a purchase, this is our random variable. So random variable X, sometimes it's called, is the number of customers making a purchase. Oops, sorry about that. So remember, a random variable, it's a numerical description of the outcomes of an experiment. So here are the possible outcomes, right? 0 people can make a purchase, 1, 2, or 3. So this is the random variable. These are the numbers that it could take on, the values it could take on, and then here are their respective probabilities. So remember, the probability distribution describes how the probabilities are distributed over the values of a random variable. So that's exactly what this is. This is a probability distribution. Well, actually, this is a graphical representation of it, but this basically, the probability distribution would say for 0 the probability is about 0.35. For 1, it's about 0.45. For 2, it's about 0.20, and then whatever it is for 3. So again, we have the random variable X, which is the number of customers making a purchase. It takes on 4 different values, and then the probability distribution says for that random variable, what are the probabilities associated with those values of that random variable. So that's the big picture. So why do we care about this? Well, the whole idea is that we can use probability distributions to calculate the probability of events. So like I said before, what's the probability that one customer will make a purchase? It's about 0.45, so it's somewhat likely that they'll make a purchase. You could say, well, what's the probability that at least 2 people would make a purchase? Well, you just add the probability for 2 and for 3. So ideally what's happening in the big picture is that we will take for this chapter discrete random variables. We will learn how to calculate these probabilities, how to create this probability distribution, so these different values that are on this graph, and then use that to calculate the probability of different events. So that's kind of the big picture. There's some more slides here that talk about what a discrete random variable is, what a continuous random variable is, and then there's a couple images here that show you the difference between discrete random and continuous random variables, and then that gives you examples. So for example, random experiment would be flipping a coin. The random variable X would be the face, and then the possible values or outcomes of that random variable would be heads or tails. So we assign a 1 for heads, a 0 for tails. Another example would be if you roll a die. The random variable x is the number of the dots showing on top of the die, and then here's its possible outcomes and their values. So what we could do is we could create a probability distribution, right, for each of these outcomes, these values for the random variable x. So these are all equally likely, so this would be 1 over 6, 1 over 6, and so on. So we could create that probability distribution to then calculate, hey, what's the probability of rolling a 3? Well, it's 1 out of 6. We know that. That's pretty simple just because it's simple math. It's stuff that we've seen before. But obviously, as we get to more complicated examples, we'll have to better understand how to create those probabilities. So that's the overall idea. Like I said, in another video, we'll learn how to actually calculate those probabilities to create the probability distributions.